Hello everyone, and my dear students of first year, today we will see one more application of matrix, that is Cayley Hamilton theorem. So let us see the statement of Cayley Hamilton theorem. Every square matrix satisfies its own characteristic equation. Every square matrix satisfies its own characteristic equation. So what is our characteristic equation here? For 3 by 3 matrix, we can write lambda cube minus s1 lambda square plus s2 lambda minus determinant of A is equal to 0. This is our characteristic equation. In place of lambda, if I substitute A, then I get here A cube minus s1 A square plus s2A minus determinant of A into I is equal to 0, because when I replace lambda by A, I get matrix there, and to add some number in matrix, we have to multiply it by identity matrix. That's why I have to write mod of A into I equal to 0. So this equation is true for every matrix. So every square matrix satisfies its own characteristic equation. So here in general we write, suppose my equation is for order n, a0 lambda raised to n plus a1 lambda raised to n minus 1 plus dot 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 a n equal to 0, then put lambda equal to a, you will get Cayley Hamilton theorem. a0 a raised to n plus a1 a raised to n minus 1 plus dot 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 an into identity matrix is equal to 0. Always keep in your mind, whenever we write lambda equal to a, at that time I have to add this identity matrix there. Okay, I have to write it properly, because we know we write a minus lambda I, means for addition or subtraction of some number from the matrix, we have to take that identity matrix. That's why we consider here. Just keep in your mind, we need here characteristic equation, means a minus determinant of a minus lambda I equal to 0, correct? But we know for 2 by 2 matrix, what is the characteristic equation? It is lambda square minus s1 lambda plus determinant of a equal to 0 for 2 by 2 matrix. Now in place of lambda, just write down a, you will get a square minus s1a plus determinant of a into I is equal to 0. So this equation is called our Cayley Hamilton theorem, and it is satisfied by every square matrix. Understood? For 3 by 3 we have written, now 2 by 2 we have written. We have to concentrate only on 3 by 3 and 2 by 2. So do we solve one example here? Okay. So let us take the first example. A simple example we start with. Example is, verify Cayley Hamilton theorem. Verify Cayley Hamilton theorem for A is equal to, see the matrix, 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2, and hence find A inverse. We will see the procedure how to find A inverse, but right now we just concentrate on finding characteristic equation. So here 3 by 3 matrix, we have to verify Cayley Hamilton theorem. Yes, we will do it. For 3 by 3 matrix, what is the characteristic equation? Lambda cube minus s1 lambda square plus s2 lambda minus determinant of A equal to 0. Correct? Now I required s1, s2, s3, determinant, all values. So let us start. Here s1, sum of diagonal elements 2 s1 is equal to 2 plus 2 plus 2. Correct? Sum of diagonal elements. So I get 6. Then s2, we know how to find s2. Minors of diagonal elements. So here first minor, 2 minus 1 minus 1 2. Second, again 2 1 1 2. Third, yes, for third, 2 minus 1, minus 1, 2. And if you solve this, 4 minus 1, it is 3. Here also 4 minus 1, 3. And 4 minus 3, 3. So it is 9. Yes, 2 is 9. Now similar way, find the determinant of matrix. Yes, 2 into, here 2 into 2, 4 minus 1. So 2 into 3. Then minus of minus 1, minus of minus 1. So it is plus 1. Correct. And next one is, what I get? Minus 2. Minus 1 into 2. So here minus 2 plus 1. Minus 2 plus 1 is minus 1. Plus 1 into 1 minus 2. So it is minus 1. So our answer is 4 by doing calculation. 6 minus 1, it is 4. Getting determinant. So we get all values. Which values we get here? We get S1, we get S2, and we get determinant. So what is our characteristic equation? Lambda cube minus 6 lambda square plus 9 lambda minus 4 is equal to 0. Understood everybody? So this is our characteristic equation. Now in place of lambda, write down A. लॅम्बडाच्या जागेवर A टाका. In place of lambda, write down A. What will we get? A cube minus 6A square. A cube minus 6A square plus 9A minus 4 into identity matrix is equal to 0. As I told you, whenever we write lambda equal to A, at that time we have to take identity matrix for the constant. So here A cube minus 6A square plus 9A minus 4I is equal to 0. Means this is our Cayley Hamilton theorem. We have to show that LHS is equal to RHS to verify Cayley Hamilton theorem. So what are the terms in LHS? In LHS I required A. Yes, it is the given A. Then I need to find A square and A cube. Okay, let us try. Find A square and A cube. So here A square is equal to what? A into A. So write down matrix A into matrix A. Here if you see the matrix 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2, some form is there, and that form we will use to find A square also. See, if you find first row only, then also you can able to write whole matrix. There are some matrices exist, we can write easily. So here 2 into 2 it becomes 4. Then minus 1 into minus 1, it is plus 1. Then 1 into 1, I get plus 1. So it is 6. Understood? So first number is 6. Correct? Do it similarly. The next one, first row, second column. First row, second column. Yes. What I get? Minus 2, minus 2, minus 1. So here I get minus 5. Correct? Do the next one. 2 minus 1 into minus 1, I get plus 1. And here 1 into 2 is 2. So here I get 5. Correct? So here I get 6 minus 5, 5. Correct? Now from that, using this 2 minus 1 1, I can write the next value. You can do your calculation, or you can write directly with me. 6 minus 5, 5. Now observe the same trade. Minus 5, 6 minus 5. Then 5 minus 5, 6. Understood? Similar way we can find A cube also. A cube is nothing but what? A square into A. So A square already we found into A. So again find first row and we will write the matrix directly. So here 6 into 2, it is 12. Minus 5 into minus 1, plus 5. 5 into 5, 5 into 1, that is 5. So I get here 12 plus 5 plus 5, it is 22. So first element is 22. Do it for the next one. Minus 6, then minus 10, and last one is minus 5. So here it get minus 21. Then 6, Next one is plus 5 and plus 10. Correct? Again it is 21. Understood? So we get first row here. Use the trick and write down the next one. What is the next one here? Minus 21, 22, minus 21. 21 minus 21, 22. Understood? Okay. Now consider LHS. What is our LHS? What is our LHS? A cube minus 6a square plus 9a minus 4i equal to 0. Write down a cube, then minus 6 into a square plus 9 into a minus 4 into identity matrix 1 0 0 0 1 0 0 0 1 and is equal to 0 0 0. You can check, it becomes 0. See here, 22 minus 6 into 6 36 plus 9 into 2 18 and minus 4. If you do this calculation, you will get 40 minus 40, it is 0. So this first number is 0. You can try for all. You will get 0 0 0 0 0 0 means is equal to RHS. Therefore, Cayley Hamilton theorem is verified. So we have verified Cayley Hamilton theorem. Means what we get? We get a cube minus 6a square plus 9a minus 4i is equal to 0. This is our first equation, or you may call we get this equation. Okay. Now to this equation I have to find A inverse. So multiply it by A inverse. Multiply this equation by A inverse. If you multiply by A inverse, I get, you may pre-multiply or post-multiply, doesn't matter. Suppose you have to find, instead of A inverse, you have to find A raised to 4, then multiply this equation by A only. I get A cube into A raised to 4. Suppose I have to find A raised to minus 2, means multiply this equation by A raised to minus 2. जी value काढायची त्याने multiply करा. So here we have to multiply by A inverse. So multiply by A inverse into A cube minus 6. A inverse into A square plus 9 A into A inverse is identity, minus 4 A inverse is equal to 0. Correct? So what I get from this? From this equation I get A square 3 minus 1 2 minus 6 A, because A inverse into A square, plus 9 into identity matrix, A into A inverse is identity, minus 4 A inverse is equal to 0. Now find value of A inverse. Find value of A inverse. Therefore A inverse is equal to 1 by 4 A square minus 6A plus 9I. Now put the values. Put the values here. We know the matrix A square. We know the matrix A, and we know identity matrix 1 0 0 0 1 0 0 0 1. Do your calculation and you will get the answer 1 by 4, 3 1 minus 1, 1 3 minus 1 3 1 minus 1 1 3. You can do it. 6 minus 12, 6 minus 12 plus 9. What will you get? 6 minus 12 plus 9. Yes, getting 3? Right. So in this way we will find inverse of a matrix. One more example we will see in our next video.